All right, we are talking about simplifying radicals. Now, this is something that we've talked about last year in Secondary Math 1, but it's going to lead into our upcoming unit, okay? So, radicals. Radicals is just another word when we see this symbol right there, the square root symbol, okay? So whenever you see the square root symbol, think radical. Alrighty, so number 1, it's asking us to write down the first 14 perfect squares. So let's go ahead and start with 0, because 0 is 1. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. Okay, so make a list that looks just like that, from 0 to 13. These are our first 14 perfect squares. Okay, and what I mean by that is what we're going to do is we're going to multiply each of these numbers by itself and see what we get. So, zeros times 0, which we can also rewrite as 0 squared. Okay, well, what is 0 times 0 or 0 squared? It's just 0. Okay, let's do the same thing. 1 times 1, which we can also write as 1 squared. 1 times 1 is 1. Okay, 2 times 2 or 2 squared. 2 times 2 is 4. Do the same thing, 3 times 3 or 3 squared. 3 times 3 is 9. 4 times 4 or 4 squared. 4 times 4 is 16. 5 times 5 or 5 squared. 5 times 5 is 25. We're just going to keep going. 6 squared or 6 times 6, 36. Notice I am writing these numbers in a different color. There's a reason for that. 7 times 7, 7 squared. 7 times 7 is 49. 8 times 8 or 8 squared. 8 times 8 is 64. 9 squared or 9 times 9 is 81. 10 times 10 or 10 squared. 10 times 10 is 100. 11 times 11 or 11 squared, 121. Last ones, 12 times 12 or 12 squared is 144. And last one, 13 times 13 or 13 squared. I'm actually going to double check this so I don't get it wrong. 13 squared. Yep. Is 169. Okay, now there's a reason that we wrote all of this list. Okay, these numbers in blue are what we called perfect squares. Now, you might ask, why is it called a perfect square? Okay, well, let's go ahead and draw a picture. If we draw a picture of a square, and you might have remembered these from math a few years ago, these are called arrays. Okay, multiplication arrays. So I'm going to split it into 3 columns times 3 rows, or however you say it. I always get rows and columns mixed up. Anyway, okay, so what this is saying is 3 times 3. Okay, well, how many boxes do we have within this square? 1, 2, 3, 4, 5, 6, 7, 8, 9. And look at that. That's the exact same answer we got over here. 3 times 3 is 9. They are literally called perfect squares because if you draw them out, they create a perfect square. Same length, same width. Okay? There we go. Okay, now what we're doing when we're simplifying radicals is we're trying to get pairs because not all of these numbers underneath these radicals are listed as our perfect squares. Okay, so what you need to remember is that there's always an invisible 2 right there. That's where the squared comes from. So we're trying to get pairs of 2. Okay, so what we're actually going to do is we're going to break down these numbers because I don't see 150 on my list. Okay, it goes from 144 to 169. So 150 is definitely not a perfect square. Okay, so what we're going to do is we're actually going to break this down. When I say break it down, I mean divide it until we can find pairs. Okay, so I'm going to divide this 150. I see that it ends in a 0. So I can do 15 and 10, right? 15 times 10 would give me 150. Okay, well now I can keep breaking it down because I don't have a pair of numbers that can leave yet. Okay, so I can break down 15. 5 times 3 would give me 15. So now I'm dealing with a 5, a 3, and a 10. Still no pairs, so let's break down 10, 5, and 2. All right. All of these numbers are as broken down as they can be. So now we just need to see what numbers can pair up. Think the numbers pair up and go on a date. They get to leave the radical and go on a date. Okay, so I see a pair of 5s. 1, 2. Okay, so when they leave the radical or they go on a date, they create one couple that got to leave the radical. Okay, well our 3 and our 2, they couldn't pair up, so they stay inside. But what is it we're actually doing with these guys? Well, if we were dividing, that means we got to go backwards. We are multiplying. Okay, so our final answer is 5's on the outside. Root, we say this as root 3 times 2, which is 6. And there's our final answer. Okay, beautiful. Let's look at number 3. Okay, first thing I see is that 64 might look familiar. This is on our list, okay? But if you didn't quite remember that, that's okay. We can still break it down, okay? But you might remember that 64 can break down to 8 times 8. This is where it becomes a perfect square because nothing is left inside the radical. See, I see a pair of 8s. They get to leave my radical, but nothing is left inside. So since there's no radical left over, we know that 64 is a perfect square. Awesome job. Let's look at number 4. 180. I don't think it's on my list. We didn't quite get that high. But let's just go ahead and start breaking it down, see if it is a perfect square or if some things are left in the radical. Okay, so again, I see that it ends in a 0, so I can divide it by 10. This would be 10 and 18. 10 times 18 would give me 180. Okay, I don't see a pair, so let's keep breaking it down. 2 and 5 give me 10. And 2 and 9 give me 18. I see a pair. Okay, so we know a 2 can come out, leave my radical. But can I break down 5 anymore? No, I cannot break down 5, but can I break down 9? Yes, and 9 is actually a number we really like. It's on our list. So we can break 9 down to 3 and 3, and guess what? Another pair gets to leave. Okay, so think of this as like a double date. So we have a 2 and a 3 that got to leave my radical, and a 5 that had to stay in. Okay, well, what are we doing with this 2 and the 3? We're multiplying them. So our final answer here, 2 times 3 is 6 on the outside, root 5 on the inside. And there we go. Okay, let's look at number 5. 128, I don't think is a perfect square, so let's go ahead and just start breaking it down. Doesn't end in a 0, but I see it's an even number, so I'm just going to divide it by 2. Okay, so 128 divided by 2 gives me 64. Okay, 2 and 64, I don't have a pair yet, but remember, 64 is a number we love. Okay, because it gives us an automatic pair of 8 times 8. Okay, so I see that the 8s can pair up. They create one couple that got to leave my radical, and the 2 had to stay in. Okay, remember that when you break a number down, it disappears. So like the 128 and the 64, they're not there anymore because we broke them down to smaller numbers. Okay, so final answer, 8 root 2. Beautiful. Okay, number 6 and the rest of them, they have something that's different. So we're dealing with, and I'm going to zoom in just a little bit. We're dealing with numbers, but we're also dealing with variables. Okay, so the variables have to follow the same rules as our numbers. They have to be able to pair up. So we're going to ignore them for now, just deal with the number. Okay, so we're just looking at 80. So let's break 80 down. Okay, it ends in a 0, so I can divide it by 10. This would be 10 and 8. Okay, no pairs yet, so keep breaking down. 2 times 5 would give me 10. 2 times 4 would give me 8. Oop, I see a pair that can come out. Okay, so we have a 2 that got to come out, create one couple. But double check that there aren't more pairs that can leave. Okay, we can't break 5 down anymore, but we can break 4. And we love 4, right? 4 is on our list. And 4 gives us an automatic pair of 2 times 2. So we see that another couple got to leave. Think of it like a double date. Okay, so we have a 2 times 2 that got to leave our radical, and I'm going to leave a little space just in case anything else can come out, because now we are dealing with our variables. Okay, so let's look at our x's first. So this is x squared, meaning I have an x, I'm just going to write it down here, x and an x times x. Okay, well, can these x's pair up and leave? Yeah. Okay, they create one couple of x's. No x's had to stay inside. So now let's go ahead. Ooh, I forgot. What number had to stay inside? I almost forgot that. We had our 5, so 5 stayed inside. Okay, well, now let's look at our y's. Okay, so I have y to the 4th, or in other words, y times y times y times y. Okay, well, how many pairs of y's get to leave? I have 1, 2 pairs. So this turns into y squared. Okay, so let's go ahead and write our full answer, our total answer. So we have 2 times 2, just going to turn to 4 in front, 1x, 2 y's that got to leave, and root 5. So final answer, 4x y squared root 5. Beautiful. Alrighty, number 7. Okay, notice we've already broken down 128, right? I mean, let's write it again, but we've already done the work basically. This is 2 times 64. 64 gives us an automatic pair of 8s. Okay, so my 8s are what gets to leave my radical, one couple of 8. I'll leave a little space, and my 2 had to stay in. Okay, we're done with the number. Now let's just focus on the variables. So first I have my x's, so x times x times x, or x cubed. Now, how many can pair up and leave? We have 2 that can pair up. They create one couple, but 1 x is left inside. Okay, and now let's look at our y's. Y is also cubed, so y times y times y. Same thing. 2 of them can pair up. They create one couple that got to leave, but 1 had to stay inside. Okay, so we'll just rewrite this as our final answer. We don't have any multiplying to do, so we have 8xy root 2xy. And there we go. Okay, beautiful. Number 8. Just look at the number first. Okay, so I have 144. Okay, is 144 on our list? Always double check to see if it's one of those nice numbers. It is. Okay, so we know that 144 gives us an automatic pair of 12, or 12 times 12. Okay, so I have the pair of 12s. They create one couple of 12 that got to leave a little space. But no other numbers had to stay in. So now we just have to worry about our variables. Okay, so I have x cubed, so x times x times x, 3 times. Okay, again, 2 of these can pair up. They create one couple that got to leave, but 1x had to stay inside. And we're done with our x's. Now let's just look at our y's. I have y squared, so y times y. These guys are nice. They can both pair up. They create one couple, and no y's had to stay inside. So So our final answer for number 8, 12xy root x. Okay, remember they got to pair up in order to leave the radical. Number 9. We have 192. Now, I don't think this is a perfect square, so I'm just going to go ahead and start breaking it down. I see that it's an even number, so I'm going to divide it by 2. Okay, so we have 2, and this is going to give me 96. I don't see another nice number, so again, it's even. I'm just going to keep breaking it down. So 96 divided by 2 gives me 48. Now, you might see a pair already, so let's go ahead and just put that aside. So we have a pair of 2's that got to leave. Let's keep breaking 48 down. Okay, so I have 2 and a 24, 2 and 12. It's kind of going off to the side. That's okay. I see another pair of 2's that got to leave. Okay, so we have another couple of 2's. And let's keep breaking 12 down. 2 times 6. And last one, 2 times 3. And I see another pair of 2's. Okay, so I actually have 3 couples of 2's that got to leave. Okay, well, the number that had to stay inside and we couldn't break down anymore is 3. Okay, I'm leaving myself some space. We know we're going to multiply these guys at the end. So now let's go ahead and look at our variables. So I have x squared, or x times x. Okay, well, I have 2 of them, so they are perfect. They can create one couple. And then I just have one y. Okay, can he pair up with anything? Nope, so he can't leave. Beautiful. So now I just need to simplify this. So this is saying 2 times 2 times 2. In other words, what's 2 times 2? We have 4 times 2x root 3y. Not our full answer yet, because now what's 4 times 2? 8x root 3y. And there's our final answer. Okay, for numbers 10 and 11. The only difference here is that we have a number waiting on the outside. Well, think of this as somebody's already on a date. We're just going to save them until the end. Okay, so let's just go ahead and simplify just like we've been doing. So I have 20. Okay, so I want to break down 20. It can be divided by 10, so 10 and 2. Then I can break down 10 to 2 and 5. So I see I have a pair of 2's, 2 and 2. They got to pair up and leave. And then I have my 5 that had to stay in. Okay, we're not quite done because now we need to account for our variable. So I just have one n. Can this one n pair up with anything? Nope. Okay, and still we're not quite done. We would have been on our last ones, but now we have this 5 that was waiting outside. So this just becomes 5 times 2 that got to leave, root 5n. Okay, same thing. We're multiplying what's in front. 5 times 2 turns into 10, root 5n. And there we go. Okay, let's do that one more time. Last example. Okay, we're going to ignore the negative 2. He just comes at the very end. Let's go ahead and break down 45. So I can divide 45 by 5. This will give me 5 times 9. Okay, we love 9 because it gives me an automatic 3 times 3. So I know my 3's can pair up and leave. My 5 had to stay inside. Okay, now I just need to account for my variable. Now I have b squared, so b times b. Okay, well, there's 2 of them. They can pair up and make one couple. Okay, and we're not quite done because we need to multiply this negative 2 to the 3. So negative 2 times 3b root 5. And we'll just multiply these together. We get negative 6b root 5. And there's our final answer. Okay, those are your notes. You have an assignment that goes with it.